Hey y'all, we are looking at our final lesson of this unit, Lesson 4, Solving Systems by Elimination. We want to be able to solve systems using elimination. A reminder that a system of linear equations is formed by two or more linear equations that use the same variables, such as x and y. A solution is any ordered pair that makes all the equations in the system true. Our essential question is how are properties of equality used to solve systems of linear equations? In example 1, we are going to solve this system of equations by adding. So we have 2x plus y equals 8 and 4x minus y equals 4. The first thing we'll do is eliminate one variable. We'll do this by noticing that the sum, or adding, the coefficients of y is 0. We have positive y and negative y. If I add those together, I get 0. So you can apply the addition property of equality to essentially add the equations to eliminate y. 8 plus 4 is 12. Y minus y is 0. 2x plus 4x is 6x. So we know we don't need that plus 0, so 6x equals 12. We'll divide both sides by 6 to get that x would be 2. Now we can take that x equal to 2 and we can solve for the other variable. We'll do that by plugging 2 in for x into either of our equations. In this case, we're going to substitute it into the top equation, or 2x plus y equals 8. Again, we know that x is 2, so we simply put that in. 2 times 2 plus y equals 8. 2 times 2 is 4. And what plus 4 is 8? Well, y must equal 4. So, our solution is that x equals 2 and y equals 4, so our point is 2, 4. Let's look at solving a system by needing to subtract. Very much like the previous one, instead of our y's, we have our x's kind of match up, and we notice that if we take this minus this, we get 0. X minus x, we would get 0. So it's the same step essentially of eliminating a variable. Here the difference of the coefficients of x is 0, so we'll subtract the equations. So we take y, x plus y equals 20, and then we basically change this one all negative, as you can see from the picture. So negative x minus 5y equals negative 68. Just essentially changes everything to negative. And then we combine that. So 20 minus 68. 20 minus 68 is going to be negative 48. X minus x is 0. And y minus 5y is negative 4y. From here, we can divide both sides by negative 4 to get that y must be 12. With that y equal to 12, we will take and plug that in to one of our equations in order to solve. To me, it looks like the easiest place to plug that in is the top equation, so let's do that. X plus y equals 20. X plus 12 equals 20. So x must be 8, because 8 plus 12 equals 20. So now we have our answer for this problem. The solution is that x is 8 and y is 12. So we have the point 8, 12. The next one is for you to try. You can see that we are adding to eliminate s and then solving for r. So add those together. What is your new r? Hopefully you see that 3s minus 3s is 0. Then in step 2, take what you get for that r value, plug it in, solve it out to figure out what S is. Let's take a look at our final example, solving a system of equations by multiplying. So we saw how we can add and subtract, and now we're looking at the situation of what if we don't have something that matches up right away. So here we have a problem. The difference of the length and width of a rectangle is 3. So that means our length minus our width is 3. What are the length and width of the rectangle? We can see it gives us the perimeter is equal to 26. So we can write a couple of equations to mimic this. First is we know that to find perimeter, we take, so we know perimeter. We know it's length plus width plus length plus width. So P equals, we have 2 lengths, 2L, plus 2 widths, 2W. And we know in this case that the perimeter is 26, so we can write that 2L plus 2W equals 26. We were also told that the difference of the length and the width is 3. So here we have our system of equations. Now we'll eliminate one variable. We notice that the coefficients of L and W are not the same or opposites. So we are going to multiply one or both of the equations so that the variables are the same or opposite. In this case, we see that if we multiply this one, the bottom one, by 2, we will get some matching with them. So we are going to multiply everything in the bottom equation by 2 so that we get 2L plus 2W equals 26 and 2L minus 2W equals 6. So again, what we did here was multiply everything by 2. So now we can add them together because we have opposites. 2L and 2L is 4L. 2W minus 2W is 0 equals 26 plus 6 is 32. Divide both sides by 4 and we get that L equals 8. So now we know that the length is 8. Now we can take that and solve for the other variable. So we'll use L minus W equals 3, plug in that 8 minus W equals 3, and then 8 minus what gives us 3? Hopefully you can see that W must be 5 because 8 minus 5 gives us 3. So the length of the rectangle is 8 centimeters and the width of the rectangle is 5. Here's one more problem for you to try. Take a moment to try it, pause the video, and continue the video when you're ready to see the answer. Don't forget to complete your summary. You can apply the properties of equalities to solve systems of linear equations algebraically by eliminating a variable. This is an efficient method when you have like variable terms that have the same or opposite coefficients, or when one or both of the equations can be multiplied so that the like variable terms have the same or opposite coefficients. Your next steps are to submit your 6.4 notes, complete your Build 6.4, and take your 6.4 mastery check. Good luck!